Okay, let's go over homework 4.3 number 9, just finding the inflection point. All right, so we need to take the derivative twice. So first derivative, f prime of theta is equal to, so that's going to be negative 2 sine of theta. All right, then general power rule, so it's a 2 in front. You have a cosine of theta, then multiply by derivative of cosine, so it's negative sine of theta. All right, then simplify that, then you will get, let's see, this is going to be negative 2 is in common, so we have negative 2. So I'll pull negative 2 here and also negative 2. Also sine is in common, so I'll probably pull out the sine of, say, theta as well. So sine of theta here and a sine of theta here. So what's left is going to be 1. And then you have plus cosine of theta. So plus cosine of theta. Right? So that's the first derivative. So let's take another derivative. So f prime, double prime of theta is going to be equal to, all right, so I'm going to just put the negative 2 outside, then take the derivative of these two guys using product rule. All right, so derivative of the first is cosine of theta. All right, then second, so it's going to be 1 plus cosine of theta. All right, plus first guy, so it's just sine of theta. And derivative of the second is going to be negative sine of theta. Right? So then we just need to simplify a bit. So this is going to be, I'm going to just multiply out. So you have a negative 2 is outside, right? Then you have a cosine of x times 1. So it's cosine of theta, right? Cosine of theta times cosine. So it's going to be plus cosine squared of theta, right? Then here you have a sine theta times negative sine theta. So it's going to be negative minus sine squared of theta, right? So that's the same thing as, so this is the same thing as negative 1 minus cosine squared of theta. Since everything else is written in terms of cosine, it's probably better to rewrite it in terms of cosine. So that's cosine squared minus 1, right? So we'll put that in. So you have cosine squared of theta minus 1. Right? So put them all together. You're gonna get let's see, it's gonna be a negative 2. Right? So you have 2 cosine squared of theta. So 2 cosine squared of theta. And then you have a 1 cosine of theta. Right? So that's this guy. And then minus 1. So minus 1. All right, so I'm gonna go down here. All right, then we should be able to factor it out. So it's negative 2 outside. All right, so we can factor it out as, right, probably you have a cosine, 2 cosine of theta here and 1 cosine of theta. So we have to get -1. So it's going to be, one of them has to be +1, the other one has to be -1. We have to get a positive sign, so we need to put the positive sign here, so that you have 2 times 1 is +2, and -1 times 1 is -1, which gives you +1. Alright, so we set that equal to 0 to find the x coordinates of the possible inflection points. Alright, so from here we can set, let's say cosine is cosine of theta is equal to 1/2, right? And or cosine of theta is equal to -1, right? So cosine of theta is 1/2. So let's do a unit circle. So draw a unit circle there. All right. Right, so we have that. So we want the cosine to be 1/2. Cosine represents the x coordinate. So 1/2 is right around there. So this is 1/2. Right, so we just need to find the angle here. Would be 60 degrees. So it's going to be pi over 3. Right, then here, this guy, so it's going to go all the way around to here, so that's going to be 5 pi over 3, right? So this gives you that the theta is going to be pi over 3 and 5 pi over 3. You know, if it, you know, theta is between 0 and 2 pi, so we don't have to have you know, bigger angles or smaller angles. All right, so then cosine of theta is -1, so it's actually -1 is right here on the x-axis. So obviously angle all the way to here is pi, so theta is equal to pi. Alright, so we need to do a number line here. So we're gonna do from 0 to 2 pi. Right, so 0 is here. Then we mark these places. So pi is right in the middle. So here's pi. Alright, so then you have a pi over 3 is over here. So this is pi over 3. And then 5 pi over 3 is right around there. So 5 pi over 3. Right? Then we just have to look at the signs. All right, so we can try something like f double prime of pi over 6. All right. So then we just look at the sign of this. So if it's pi over 6, then you can see that this is going to be negative. So we have let's see. So what is that, negative? So pi over 6 cosine of pi over 6 is actually, sorry, this is going to be positive. All right. So this guy is going to be positive there. And then a pi over 6 cosine, so this is going to be positive, right? So we can see that the negative, positive, so it's going to be negative here. All right. Then between pi over 3 and pi, so it's going to be, let's say, so let's do nothing really specific. We can just try. So angle is going to be right here. So it's going to give you this value is going to be cosine value smaller than 1/2, so it's going to be negative here. Right, that's probably easier to do. And because this guy is actually positive, so it's going to be negative, so it's going to be positive here. Right. All right, so let's look at the angle between pi and 5 pi over 3. So we're looking at the angle here, or we can try, you know, 3 pi over 2 or something like that. But anyway, So we just have to look at the sign. Right, so cosine of 2 cosine of theta minus 1, it's going to be negative because the cosine value could be negative here, so that's going to be negative there, right? Then after that, so it's negative, and cosine of theta plus 1, so that's going to be positive, right? So you can see that it's still positive here, right? So any angle between 5 pi over 3 and 2 pi, so it's going to be over here. So we can see that cosine 2 cosine of theta minus 1 is going to be now positive. Right? This guy is going to be always positive because you're adding 1 to it, because best we can do is negative 1. So it's going to be positive, so it's going to be negative there. Alright, so you can see that concavity change only occurs right here. So there's going to be an inflection point there. And the concavity change occurs right here. So it's going to be an inflection point there. Alright, so we can see, so we can just find the y, corresponding y value at pi over 3. Right? Alright, so it's going to be 2 times cosine of pi over 3 would be 1/2 plus 1/2 squared, so it's going to be 1/4. So maybe I should write it as a 1/2 squared. Alright, so this is going to be 1 plus 1/4, so it's going to be 5/4. Alright, and then we look at 5 pi over 3. Alright, cosine of 5 pi over 3, again, it's 1/2, so it's going to be exactly the same. So it's 5/4. Alright, so inflection points. So therefore, inflection points are, it's going to be pi over 3, comma, 5/4, and also 5 pi over 3 and 5/4. Right? So those are the inflection point. All right, let's see. Let's just use the software to sketch the graph and see if it agrees with what we have. So here's the picture. Right? So you can see that this is around the pi over 3, so there's an inflection point because you have concave downward here, and then you have a concave upward. So, and it's a 5/4, so it's around there. All right, and same thing, this is going to be around here. It's going to be 5 pi over 3 is around here. Right, so it looks like the picture agrees with what we have here. Right, this is it. I hope that this was clear.